Assalamualaikum and hi. Today we as a group 1, section 2 solid mechanics would like to present our project titled Parthenon Straw Tower. Our group has 4 members. First, Ahmad Zahid. Second, Muhammad Nur Azrai. Third, Mak Zain Wei. Fourth, Eng Pei.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nadra Ibn Zahari. My matrix number is CN200046. I will explain you about problem statement here. That first, how much load that can be lifted by the prototype, and the second, what is the suitable formula that can be used to help the prototype lift the load, and then the last, what is the best design for the prototype to lift the different mass of load. For the background study, the tower structure of straw must be designed to withstand numerous forces or loads. From the chapter in the solid mechanics that we have learned about how this force act on one another. If force occur on a structure of the tower that are more heavier than what the structure is built to withstand, the tower could be lifted. It also could be filled to lift the load based on the creativity and tech in the design. There are 5 important things that should be in the prototype, which are compression, tension, shear, bending, and torsion. These important things could help the student to find the best solution to find the weakness of the prototype in the trial and improve the prototype until the weakness from the straw tower could be solved. Student can use other material to make the prototype becomes more stable. For beginning of the project, students should know the step of engineering design process. It is empathize, define the problem, generate idea, make a prototype, test, and finally is result or redesign to make improvement on the prototype design. For the project, we need to make a prototype from straw to lift a 30 kilogram load. The prototype need to success to lift the load. The dimension of the prototype was given, which a range of length is 25 cm, in width the range of length is 25 cm, and the width is 25 cm, and the height is 30 cm. The tower must be not over than 0.7 kilograms.
My name is Mak Zain Wei, and now I will continue with the objective of our project. So the first one is to understand the importance of prototype when building structure. The second is to be able to apply strategic design into our prototype. And the third is to investigate the maximum force that bearing tower can withstand. Next is the scope of our project. Is definitely to make a prototype that can withstand heavy loads. So next, we will look about the literature review. Before we making our prototype, we are as a designer must have some problems. We are confused. The first is the shape of prototype which should be constructed, or the nature of our prototype in terms of material. Can our prototype withstand the load for above 10 kilograms, or the form of testing which should be applied to the prototype. So next is the prototyping process during our project. The first design we made was failed when testing the prototype by putting 10 kilograms of wood. The pin of our prototype bends and break after about 30 seconds. We observed that the main reason of this happened was the number and the thickness of the bins, because we are using 4 bins for our first prototype, and it was filled to lift the roof. For the second try of prototyping, we have designed based on the design Parthenon, which is a historic building in Greece, as our citation of buildings. It has a strong support in its design to help the prototype to lift the roof in a certain way. Thus, we are increasing the number of pins based on the pillar in the first try. We decided to add a supported walls inside the prototype to ensure the larger surface of prototype contact with the roof. And finally, our prototype lift the 13 kilograms root successfully for 1 minute. So next, I will list about a concept we use for our prototype. First one is torsion, second one is column, third one is stress, and the fourth is bending moment. So this is all from me. Thank you.
Hi, my name is Ahmad Zahir. My metric number is EN200172. I want to present about methodology. First, the conceptual design. Our prototype design concept idea was inspired by a historic building, the Parthenon at Athens, Greece. Parthenon building has a rectangular structure. It was built in the middle 5th century before the Common Era. Next, the development stage of design. There are 6-stage process of design. First stage is empathy. To gain an empathic understanding of the problem you are trying to solve with your team members. Second stage is define. To determine the core problem we have identified. Third stage is ideate. Ready to start generating ideas and think out of the box to solve the problem statement. Next, prototype. Make a prototype according to the final decision that has been made at the ideation stage. Next, test. Test the prototype to find out the result. Last stage is result. Result will be recorded and reported. Next, fabrication of the prototype. Parthenon straw tower is made from straws and tapes. This is the final model of Parthenon straw tower. Next, results of test load. Our group used load of 4 types. Our prototype is capable of withstanding all types of loads. This is the result table of straw tower whole load in 1 minute. Next, this is some picture of the Parthenon straw tower that has a load on it. Next, this is hand sketching drawing before we transfer to engineering software such as SolidWorks. Okay, this is our prototype sketching. We use SolidWorks 2019.
Hi, I'm Eng Pei Yi, and my matrix number is AN200205. I'm going to continue with the calculation of our model prototype. Firstly, on the top left corner, it is the sketch and the dimensions of our prototype model. Okay, so first step, we're going to calculate the weight of each mass of load tested, and we'll be calculating it by multiplying the mass of the load with the gravitation acceleration, which is 9.81 meters per second squared. And the next, we'll be calculating the area. For the area, we'll be taking the top area of the model. So it is 244 millimeters multiplied by 244 millimeters, and therefore we can calculate the area. Next, we'll be calculating for the stress from the load to the top of the model, which is sigma equals to F divided by A, where F is the weight of the load. And next, the area is the area of the top view of the model. Next is strain, which is epsilon equals to sigma divided by E, where sigma is the stress calculated above, and E is the modulus of elasticity of the material used, and in this case the E is 1.5 gigapascal. Next, we will be calculating for the calculation of column. The whole model is being seen as a single rigid body. So firstly, moment of inertia, which is I, can be calculated using the formula BD cubed divided by chart, where B is the length of the base of the top view of the model, and D is the length of the height of the top view of the model. And next is PCR, which is the critical load, and the formula is pi squared EI divided by KL squared. E is the modulus elasticity, I is the moment of inertia, K is a constant depending on its n-type support, in this case is 2, and L is the actual length of the column, or in this case the height of the whole model. Next, we'll be calculating for the bending moment. We'll be considering the model as a single rigid body as well. So maximum bending moment Mmax can be calculated using W equals to L squared divided by 8, where the W is the maximum weight tested onto the model and L is the length of the base of the top view of the model. Next is maximum normal stress due to bending, sigma m. The formula is mc divided by I. M is the maximum bending moment and c is the vertical distance from the neutral axis and I is the moment of inertia. Next, we'll be using the formula of maximum shear stress. For max equals to sigma x divided by 2 and the formula square root of sigma x minus sigma y divided by 2 square plus tau xy square, and we'll deduct the value of tau xy from the equations above. For the next one is for the stress formation, which is Mohr circle. So from the calculations before, we will get sigma x, sigma y, and tau xy. And firstly, we'll be calculating the average normal stress, which is sigma average, can be calculated using the formula sigma x plus sigma y divided by 2. For the coordinate of point C, x coordinate is the average normal stress and the y coordinate is 0. And as for point A, the x coordinate is sigma x and the y coordinate is tau xy. For the radius of the Mohr circle is also equals to the maximum in plane shear stress, tau max, which can be calculated using the formula square root of sigma x minus sigma y divided by 2, the whole thing square, plus tau xy square. And next, we'll be calculating the principal stress, sigma 1 and sigma 2. The formula is sigma x plus sigma y divided by 2 plus minus the square root of sigma x minus sigma y divided by 2 whole thing square plus sigma xy square, which is also equals to sigma average over tau max. And lastly, for the orientation of element, theta p can be calculated using the formula tangent to theta p equals to tau xy over sigma x minus sigma y divided by 2. So the next is the Mohr circle. That's all from me. Thank you.
Based on the prototypes that have been tested to lift our different load and tests are successful to lift the loads, the structure of the prototype of the straw or the straw have a strong or stable structures. The engineering design process also helped the prototype could be finished to make it in its time. For the stability of the structure of the prototype, we use the formula from the torsion stress, column, and bending moment. Torsion will occur whenever a structural element is subject to a twisting force. Torsion also expressed in the Pascal and SI unit for Newton per square meter, Newton meter, or foot-pound force, feet lbf. Stress is force per unit area that the force acts on it. It could be compressed or tensile. Its unit is Newton. Columns are used in the structure of the prototype as structural reinforcement, much like beams. Bending moment is a measure of the bending effect that can occur when an external force or moment is applied to a structural element. It important concept to calculate where and how much bending may occur when forces are applied. Recommendation. For the recommendation in this project, first, student needs can use plasticine clay to put in the straw to make a stable or make a strong fit for to the prototype, so it could to lift the load in a heavy load. And the plasticine clay also will help to increase the stability in the structure of the prototype. And the second, student can increase the area of the prototype to help the prototype become more stable to lift more heavy load. That's all. Thank you.